Welcome to the third part in our series on indices. This is looking at rule number 3 today, and we have already looked at what happens if we multiply terms together, what happens if we divide terms by one another, and today what we're looking at is rule 3, which says if you take a base A and raise it to a power of m, and then take that whole thing and raise it to another power, how do we process those indices today? Okay, and as you can see, the rule just says take that base and multiply the two indices together, okay, m times by n. And like yesterday, we're going to try and have a quick look at why that's the case, and how this is a quicker version of what we could possibly do. And we're going to look at it in full again with example 1 here, which is 2 cubed squared. The bit in the bracket, let's think about it, it's 2 cubed, so that's 3 2's multiplying together, and we want to square something. Now when we square something in maths, what we do is we multiply it by itself. So another way we could write this question is 2 cubed multiplied by another 2 cubed. And this actually becomes a question that is now using rule 1 of indices, one that hopefully we know quite well by now. And what we know about that rule is if we want to multiply terms together, then we simply add the indices. We keep the base the same, so the base is 2, and we add those indices. 3 plus 3 is 6. And what we're trying to do with rule 3 here is we're trying to kind of cut this middle step out. If we look at 3 plus 3, we get 6, but actually we can get 6 from these two indices in the first part of the question. So really we can jump from here straight to there by doing this rule. Take the two powers and multiply them together. So 2 is the base, 3 times 2 gives me the 6. Let's see if we can do that with the second example. So this time we've got b cubed, and we're wanting that whole thing multiplied by itself 4 times. Okay, the base stays the same. And what we're doing with the indices in this rule today is we are multiplying. Yeah, so 3 times 4 gives me my new power, which is b to the power of 12. Again, we can increase the challenge ever so slightly by adding in some negative indices. The negative could be inside the bracket, outside the bracket. It doesn't matter as long as you're confident with your integers work. We're going to look at our base again. It's base A in this case, and simply all we're going to do is multiply the two indices together. So negative 7 multiplied by 2, we've got a negative times by a positive, which result in negative, and we get negative 14 as the solution to that one. One final example, looking at what happens if we've got, like in the other days, a coefficient in front of x. And remember, if you think back to what we did previously with those, we've got we do what the operator tells us. Okay, so what is it we're being told to do here? We're being told to take this term and cube it. Yeah, take this term and cube it. And so to get the number, or the new coefficient at the front, we're going to take our 2 and we're going to cube it. How do you cube 2? Well, I'll just take a wee note under here. 2 cubed means 2 multiplied by itself 3 times. So 2 cubed is just 8. So we're going to write that as 8. And then we can focus on our new section, which is here, which is x to the power of 5, all cubed. And remember, these don't behave the same way the 2 did. This is where our rule of indices applies, because these are indices, whereas this is not. We're going to take our 5 and multiply it by our 3. What's the base? The base is x. 5 times 3, our new index, is 15. That's rule 3. You've now seen the first 3 rules of indices. I'll do a little video looking at what happens when we start to combine all of those rules. But for the moment, you can have a little go at today's task.